You ever wonder how architects get those walls to meet at a perfect corner? Or how city planners lay out a street grid that's just perfectly straight? Well, the secret is all in the math of parallel and perpendicular lines. And look, it might sound complicated, but I promise you, it all boils down to two super simple rules. Once you know them, you can write the equation for pretty much any line you'll ever need. So, let's dive right in. Before we even think about an equation, just look around you for a second. Think about a highway, right? Those parallel lines just stretching out to the horizon, never, ever touching. Or maybe the perpendicular lines of a window frame, meeting at this perfect, clean corners. You see, this isn't just some abstract math concept. It's literally the hidden blueprint of the entire world we've built.
So here's how we're going to break it all down. First, we'll start by really seeing these lines out in the wild. Then, we'll uncover the two simple rules that control how they relate to each other. After that, we'll use those rules to actually build our own equations. And finally, I'm going to leave you with the one key idea that you should take away from all this.
Okay, first things first. Before we can start writing equations about them, we need to be totally crystal clear on what these lines are. So let's meet our two key players.
So what really makes a line parallel? I want you to picture a set of train tracks. They run right alongside each other forever and ever, always keeping that exact same distance apart. They will never ever cross. That right there is the whole idea of parallel lines. They're on the same journey, just on different paths.
And then on the other side, you've got perpendicular lines. Now these lines definitely meet, and when they do, they cross in a very specific way. They form a perfect 90-degree right angle. Think about the corner of a square, or where two streets intersect perfectly. That sharp, clean corner, that's the signature of perpendicular lines.
All right, now let's see if we can translate that train track idea into the language of math. In algebra, the direction and the steepness of any line is defined by just one thing: its slope.
And this, my friends, is the golden rule. It's really that simple. For two lines to be parallel, their slopes have to be exactly the same, identical. If one line has a slope of, say, 2, any line that's parallel to it has to have a slope of 2. No exceptions. They're pointing in the exact same direction.
Okay, so if parallel lines are all about being the same, you can probably guess that perpendicular lines are, well, all about being different. Their relationship is a little more involved, but it follows this really neat, predictable two-step rule. This is it. This is how you find the slope of a perpendicular line. You take the original slope, you flip it upside down, that's the reciprocal part, and then you switch its sign. So from positive to negative or from negative to positive. That's the opposite part. Just remember this little mantra: flip and switch.
So let's put these two rules right next to each other, because this is the core of everything. On the left, for parallel lines, the slopes are identical. Easy. On the right, for perpendicular lines, you do that little two-step dance we just learned. You flip the fraction and you switch the sign. So it's either same or flip and switch. That's the whole game right there.
Okay, so we've got the rules down. Now what? Well, now for the fun part. Let's actually use them to build something new. We're going to write the equation of a brand new line, all based on its relationship to another one. And it's a really simple three-step process. First, you just need to identify the slope of the line you're given. Second, you apply the right rule. Is it same for parallel or flip and switch for perpendicular to figure out your new slope? And finally, you just use that new slope and a point you're given to build your final equation. That's it.
Let's try one. Say our original line is y equals 3x plus 5. Okay, step 1, find the slope. That's easy. It's right there. It's 3. Step 2, apply the rule. We want a parallel line, so our new slope is also 3. It's the same. Now, step 3, we build the new equation. We know our new line looks like y equals 3x plus b, and it has to pass through the point 2, 1. So let's plug those numbers in. We get 1 equals 3 times 2 plus b. That means 1 equals 6 plus b, so b has to be negative 5. And there's our final equation, y equals 3x minus 5. See? Same slope, just a different starting point.
All right, now let's try a perpendicular one using that same original line. The slope is still 3, but this time we do our flip and switch. So we flip 3, which gives us 1 over 3, then we switch the sign, making it negative 1/3. That's our new slope. Now we know this new line has to go through the point 3, 2. So we plug it all into y equals negative 1/3 x plus b. That gives us 2 equals negative 1/3 times 3 plus b. Well, negative 1/3 times 3 is just negative 1. So 2 equals negative 1 plus b, which means b has to be 3.
And there you go. Our new equation is y equals negative 1/3 x plus 3.
So let's bring this all home. We've gone from just seeing these lines in the world around us to understanding the two simple math rules that define their relationship, and finally, to actually using those rules to create brand new equations from scratch.
This is it. This is your toolkit. If you remember only one thing today, please let it be this. Parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals. Just remember our little mantra, flip and switch. Honestly, everything else we did today is built on top of these two fundamental ideas.
So the next time you're out and about, I want you to look at a building, or a map, or even just a piece of furniture in your room. You now have the tools to see the invisible math that's holding it all together. So my question to you is, where do you see these rules defining the structure of your world?